Greetings, future leaders of America. Let's do some math. All right, so today we're going to talk about kind of a weird abstract thing that we're going to call complex factoring, which is how we're going to go and factor a sum of squares. Which sounds weird because we've been telling you guys for years, oh, hey, it's pretty cool. You can factor a difference of squares, but not a sum of squares. And then now you're sitting in math class and it's all like, oh, look, you can do a sum of squares factorization now. Well, you can. We just had to learn about a new kind of number before we could do it. So let's review, shall we? We know that you can factor a difference, subtraction, of perfect squares because you can use these cool things called conjugates. But you can't factor a sum of squares because the factors of positive numbers are all same sign things. So if we tried to multiply this together, we'd get x squared, and then we get plus xy, and then plus another xy, so we get plus 2xy, and then plus y squared. So you see how we got this 2xy? That didn't sum to 0, so we're kind of screwed. All right, well, what if we did minus signs? Maybe if we subtract it, we can get rid of it. Well, then we get x times x is x squared, and then we get minus xy, and then another xy, so that's actually just minus 2 xy's. Crap. So then we got negative y times negative y plus y squared. So we have our x squared, we have our plus y squared, but we got that guy in the middle. So we just haven't been able to get rid of it. And this is where things get weird. We got to put on the mathematical creativity hat. I don't know what it looks like. It's probably ridiculous. But let's try. What about if we use some properties? So let's use the fact that we could say that x squared plus y squared is actually the same thing as x squared minus negative y squared. Crazy, I know, right? Being able to write a plus sign as two adjacent minus signs, kind of weird, but you know you can do it because, a negative times a negative equals a positive. So when we subtract a negative, that's also positive. Wicked. So if we decide to maybe make some invisible math uninvisible, then we can write it with a coefficient so it looks like x squared minus negative 1 y squared. Oh, interesting. Why would we choose to write this as negative 1? Because we can use what we know about I, the imaginary number. We know that I squared is negative 1. So instead of writing this negative 1, what can we put instead? I squared. And then all of a sudden, blam! Look at that. X squared minus I squared y squared, which is the same thing as x squared minus yi squared. So even though this doesn't look like a difference of squares when we use imaginary numbers, it's a difference of squares. Isn't that amazing? See what math can do for you. All right, so we're going to use the fact that we can factor a sum of squares just like we can a difference of squares, so long as we use imaginary numbers, to go and do this stuff. So let's look at an easier example first. Let's do x squared plus 25. Your whole life you've been told you can't do this, and today is the day you can. Because you can look at this and say, ooh, perfect square, ooh, perfect square. All right, cool. What is the square root of x squared? X, bam. What is the square root of 25? It's 5. Bam. So what are we going to do with that? Well, we know it's a sum, so we got to add I to our factors. Okay, so it's going to be x plus 5i times x minus 5i. You want to check that? You want to prove it? You don't believe me? Fine. Do it yourself. Let's do some multiplication. So distributive property. We go x times x is x squared minus 5xi. Okay, and then we're going to go over here and we're going to go 5i times x is plus 5xi. And then 5 times negative 5 is negative 25. I times I is I squared. And we can see that these terms in the middle, they're gonna sum to 0, and this I squared is really negative 1, so it's just gonna change the sign there, so we do end up with x squared plus 25. Wicked cool, I know, right? And it still works even when we've got weirder things like 4x squared plus 81, because we can still take the square root of 4x squared, Okay, that's just a 2x. And we can still take the square root of 81. That's just 9. And because we know this is a sum of squares, we just do complex factoring. So it's just going to do 2x plus 9. Ah, ah, don't forget that I. And then 2x minus 9. Don't forget the I. Okay? Because if you multiply this together, you're going to end up with conjugate pairs that are going to eliminate those linear terms, your x's anyway. And then the I squared is going to change the sign of that negative 81 to a positive 81. Easy. Okay, now if we go just one teeny tiny step further than that, we can see that we can look at a conceptual example. And this one says if one factor of a real, that's an important word, real, meaning non-imaginary, only like actual numbers. So if one factor of a real polynomial is x plus 5i, what is the other factor? Okay, well, if it's got x plus 5i is guaranteed to be one factor. Well, if we multiply it by, something like x plus 3, well, if I do the distributive property, I'm going to end up with i's. That's not a real polynomial. So it definitely can't be that. Okay, I also couldn't go and just multiply it by like I, because then you'd have xi minus 5. But you see how you still have an I? That's the problem. So what do we got to use? That's right, your favorite word, conjugates. So we know it's got to have an x. We know it has to have a 5i, but the sign that's in the middle has to change. Because if I multiply these two things together, well, x times x is x squared, real. X times negative 5i is negative 5xi. 5i times x is plus 5xi. And 5i times negative 5i is negative 25i squared. But what's going to happen to all of these values for I? Well, that I squared is going to become negative 1. So this is really plus 25. These two birds in the middle, they're going to go, okay, they're going to sum to 0, and all that's left is x squared. So what do we have here? We have a polynomial that is all real, okay, because there's no i's there. So now you can go take a look at your factoring the sum of squares complex factoring worksheet. Do it. We'll give you a little cheddar for it. Thanks for watching.